let 16x squared plus 49y squared minus 96x minus 392y plus 144 equals 0. Then write the ellipse in standard form. Okay, so this is a really important problem. So when they say this, write in standard form. When we have, regular x squared and regular x, y squared and regular y, and let me back this up, and we're asked to change to that form, here's what we do. I'm going to lay out the steps for you. So step number 1. Gather x squared and x, y squared and y. Move number to the other side. So what am I talking about? I'm going to gather 16x squared and minus 96x. So 16x squared minus 96x. And I'm going to leave a blank. I should say plus a blank. Plus a blank. Then we're going to have plus 49 y squared minus 392y plus a blank equals, and then the 144, I'm going to subtract 144 from both sides, moving him to the other side. So there we go. So there's the first step. Let me put in our wall of separation here. Okay, so that's where the equals is. So we have the left side and the right side. Just want to make that clear. So step 2. Factor out the numbers that are in front of x squared and y squared. So I'm going to take out this 16. And over here I'm going to take out this 49. Okay, so if I take out that 16, what does that leave inside? 16 times x squared will go back to 16x squared. 16 times what will go back to minus 96? I don't know, divide. Whoops, it's kind of sloppy. Divide 96 by 16 in your calculator. It'll tell you 6. So this needs to be minus 6x. 6 times 16 would be 96. Over here, 49 times, and then, of course, we still have a blank here. 49y squared, and then 49 times what will go back to minus 392? Well, I don't know. Use your calculator. 392 divided by 49. I'm going to use mine as well. I'm getting 8. 8. So this has got to be minus 8y, right? 49 times minus 8y will go back to minus 392 plus a blank. So we factored out the numbers in front of x squared and y squared. Let's get rid of all this. Okay, so now step 3. Here's the crucial step. Take the middle number divided by 2 and squared, put in the blanks. So this is called completing the square. This process is called completing the square because we're trying to make it squared and squared, second power. This completes the second power. This completes it. It makes it a second power. Let's see it in action. So notice I take this middle number right here, and I go middle number over 2 squared. It's minus 3 squared plus 9. And that's what I'm going to put in that blank. You can just put regular 9. You don't need the plus sign there. So let me get rid of that. So it's just going to be 9. And then the other one, same thing, grab the middle number, put it over 2 squared. This finds the right number to make it factor as a squared. Plus 16 or just 16, that's what goes in the blank. That's how you find those numbers in the blank. But now you can't just do something to the left side without doing it to the right. So you must do the same to the left and the right sides, right? If I put in those new numbers on the left side, I've got to put them in. You can't just add brand new numbers to the left side. You've got to also add them to the right, because this is an equation, right? This left and right side are equal. So if they're equal before and you treat them the same, they'll be equal afterwards. You got to treat them the same. So now you might say, okay, well, yeah, that's easy. So I added a new a 9 on the left side. So I'm gonna add 9 to the right side. And I added 16 to the left side, so I'm going to add 16 to the right side. No, that's not correct. You didn't just add 9, did you? By putting a 9 right here, he's under the influence of a 16. That 16 is going to multiply him. So you really added whatever 9 times 16 is to the left side. Do you see that? Here's how we see it. If this 16 was to go boom, let me write it here. X squared minus 6x plus 9. If I was to multiply that 16, I would get 16x squared, and this would be 96x. No big surprise. That's what we had from the beginning, right? From the very beginning, 16x squared, back here, 16x squared minus 96x. It was over there, same thing, right? No, nothing's new there. But now 16 times 9, what is that? 90 and 144. There would be a brand new 144 that was never there before. You see, by putting this 9 right here, under the influence of a 16, you really added 144 to the left side. So let's go back here. You've got to really add, let me continue this wall here. You've got to really add, here's the original 144. You've got to really add 144 to the right side, because that's what you really added to the left by putting this 9 under the influence of a 16. And then how about for the y stuff? Well, now we have 49. In fact, let me try to do a better job on this. Here's our new 9. And then over here we have y squared minus 8y. And there's our new 16, but that isn't really 16. If I was to multiply this out and this out, that'd be 49y squared. That would multiply to be 392y. No big surprise. We already had those. Look back here, 49y squared minus 392y. Nothing new there, but 49 times 16, what's that? If I was to multiply that out, there would be a brand spanking new 784 that was never there before. So by adding this 16, this brand spanking new 16 to the left side that was never there before, under the influence of a 49, I really added 784 to the left side, so I've got to also add that to the right. Does that make sense? I got to make sure I'm really doing the same thing to both the left side and the right side. And now I am. Right? So I really added 144 to the left side by adding 9 under the influence of 16 that was never there before. And by adding this 16 under the influence of 49, I really added 784. So 144 and 784, 144 and 784 must also be added to the right side. All right. So now, factor as parentheses squared the left side. So now we're there. So this, let's go back. So we can bring this down. So we have 16. So we don't I hope this didn't confuse you. We don't need this anymore. This was just checking. So x, how does this factor? How do you get two numbers to multiply to be plus 9 and add? Remember factoring? Add to be minus 6. Minus 3, right? They'll multiply to be plus 9. They'll add to be minus 6, which means that's minus 3 squared. See how it factors as a square? It did it beautifully. Now this one, bring down the 49. Whoops, I should do it right here. 49, and I'm kind of messing this up here. Here, let me try this again. Here we go. So bring down the 49, and this will factor as y is in the front here. And what multiplies to be 16 adds to be minus 8, minus 4, minus 4. They'll multiply to be plus 16, add to be minus 8. So notice that's the same thing twice. It's a square. Now on the right side, just take your calculator out, combine those. Well, you can actually tell minus 144 and plus 144 cancel. So we just have the 784, don't we? We're one step away. Step 6. Divide through by the right side number to make it equal 1. Remember, the right side, we always have to make it equal 1 on a ellipse equation. So I'm going to divide through by 784, and then I'm gonna simplify. So 16 goes into 784. Just use your calculator. I'm getting 49, and 49 goes into 784 16 times. So we've got it. X minus 3 squared over 49 plus y minus 4 squared over 16 equals 1. Right? That right side became 1. So there we go. We did it. We transformed the ellipse equation into a nice form that we can use. See how it started off up here? Started off just a big old mess with just a bunch of x squareds and y squareds everywhere and numbers, but we did this whole thing called completing the square. The magic step was right here where we put the middle number over 2 squared. Right? We took that middle number over 2 squared, came out 9, added that, same thing on the other side, middle number over 2 squared, added that, and that did the trick. That made them factor. When we put that 9 in here, they came down and they factored as the same thing twice, which made it a square. That's called completing the square. That middle number over 2 squared does it. So now we come down to here and we have it in a really nice usable form. Now what do I mean usable? Well, now we can find the center. Let's use it. Now we can find the center super easily. How do you find the center? Remember, it's always opposite. Opposite. So the center is going to be positive 3, positive 4, isn't it? So the center of this ellipse is positive 3, positive 4. So let's find it right there. 3, 4, there's the center. And they want us to graph it. How are we going to graph it? Remember, what's underneath x, you can write that as 7 squared. What's underneath y, 4 squared. So whatever's underneath x is always right, left. So go right and left 7. Right there. See how I went right 7? 1, 2, 3, 4, 5, 6, 7. Do the same thing in the other direction. 1, 2, 3, 4, 5, 6, 7. So there's going to be the other dot. Right there. Right and left 7. And what is underneath y? That's up and down. Up and down 4. So I'll go right there. See how I went up 4? 1, 2, 3, 4. Then down 1, 2, 3, 4. It's going to be right there. So there we've got our ellipse. do the, mine always look a little pointy, but there we go. There's the general shape of the ellipse. We were able to find it starting from all this mess up here. Just this mess of x squareds and y squareds and x's. By completing the square, middle number over 2 squared, and doing all that work, we were able to get it into a very usable form where we could find the center and produce the graph quickly and easily. Now, when you go to actually do this graph on your homework, the way they have you do it is they have you click the center, which is right here at over 3 up 4, and then click the corner point. That would be right here. Do you see how there's like an invisible, I'll make it visible, box, a border that holds the ellipse? Like that. So to get the graph of the ellipse, you have to click the center and then click the corner. How do you find that corner? Well, you draw your dotted box and you find that actual corner. In mine, this corner is over 10 up 8. Why? Because you go from the center and it goes to the right. How much to the right? 7. And it goes up. How much up? 4. Right? 7 up 4 from the center, because that's what's underneath x and y. And you find the edge, the corner of the dotted box, the border that holds the ellipse inside of it. So there's the answer, and there's the way it looks more beautifully done. There it exactly is. And so there we go.